I hope you realise by now that if we're going to be adding up large numbers of terms, that can get very cumbersome and a bit repetitive and tedious. So as always, we want to find a rule that works with what we're doing here. And we want to make sure that we understand the rule. So first things first, we're going to start with our general term for an arithmetic sequence, and that is that term n is term 1 plus n minus 1 lots of a common difference. If we were going to write that out in its most basic form, our first term would simply be term 1 because it's 0 lots of the common difference, so it's just term 1 plus 0, term 1. We then know that our second term is our original term plus 1 lot of the common difference. Our third term is the first term plus 2 lots of our common difference, and so on. And we can go on for however long we like. Our last term is going to be our nth term. Given that we have to add a common difference to get to our nth term, our second last term is going to be our nth term minus 1 lot of the common difference. Same with this one. To get from our third last term to our second last term, we have to add d. So our third last term must be Tn minus 2 lots of d. So we can use these general versions of the terms of a sequence to work out the rule for the sum. So using our rule, the sum to n terms is going to be T1 plus d, our second term, plus T1 plus 2d, our third term, plus all of the terms in between, plus Tn minus 2d, which is our third last term, plus Tn minus d, our second last term, plus our last term, Tn. Now, because we're just adding all of these things together, we can write them in any order that we want and it doesn't make any difference, except that we have to keep these terms in brackets because we've got subtractions. So what I'm going to do is just rewrite the entire thing in reverse directly underneath, and it'll become apparent why in a minute. So now I'm going to start with what was my last term, Tn, my second last term, which is Tn minus d, my third last term, Tn 2d, plus all of the terms in between, plus my third term, which is T1 plus 2d, the second term, which is T1 plus d, the first term, which is T1. All right, so why did we bother doing that? Imagine this to be a giant big sum and we add them together. Over on the left-hand side of the equals, we've got 2 lots of this Sn thing. So we're just going to write 2 lots of Sn. Then here we've got, if we add vertically in our corresponding pairs, we've got T1 plus Tn. I'm just going to pop those in a bracket. If we consider this pair of terms, we've got T1 plus d plus Tn minus d. The plus d and the minus d cancel each other out, and we're left with another lot of T1 plus Tn. Same with this pair of terms. The plus 2d minus 2d cancel each other out, and we're left with another lot of T1 plus Tn. Same thing for every pair in between. This pair, Tn minus 2d, the plus 2d cancels out, and we're left with T1 plus Tn. Minus d plus d, we're left with T1 plus Tn. These last two combine to just give us T1 plus Tn. Now, how many of those lots of T1 plus Tn am I actually going to have? Well, let's have a look. This Tn represents which term in our sequence? It represents our nth term, which means we're going to have n lots of T1 Tn. So there's going to be n lots of these brackets. So we can simplify that. to 2 sum to n equals n lots of t1 plus tn. We're not interested in 2 lots of the sum, we're only interested in 1 lot of the sum, so we divide by 2 to get rid of that 2 on the left-hand side, and we're left with the sum to n terms is n times t1 plus tn on 2. And just a reminder that is for tn equals t1 plus n minus 1 lots of d. Now, the tricky thing about using this version of the formula is that you need to know the first term, which is okay. We generally do know the first term of a sequence, but we also need to know the nth term. Now, if we're working with really small numbers, that's okay. You know, you might know what the 5th term is, or you can easily calculate the 5th term. What if you're working with something significantly bigger than that, like the 50th term or the 1000th term or something like that? Yes, you could work it out, but there's a nicer way to do it. And the way to do it is to recognize that we actually know what Tn is, don't we? So we can sub in Tn equals T1 plus n minus 1 lots of d, and we get Sn is n outside of T1 stays the same, and then we substitute this whole thing in where T2 was. And so it's going to be T1 plus n minus 1 lots of d, and still divided by 2 because that's part of the rule. Then we can collect these two T1s, 1 and 2. So it's n outside of 2 lots of T1 plus n minus 1 lot of our common difference divided by 2. So there you've got 2 different versions of the rule. One which uses the first term, the nth term, and n. The other one which uses the first term, n, and our common difference. So they both will prove useful. You need to make a note of both of them and when to use them. When do you use them? We'll go through some examples now.